In this section, we're going to discuss linear functions. So first, let's define what a linear function is. So, a linear function is a function that can be written in the form y equals mx plus b. M and b are real numbers, meaning they can be any constant number from the real number line, and then x is your independent variable, and y is your dependent variable. Now, just like we can write numbers in different forms, like we can write it as a decimal or a fraction or a percentage if we're using percentages or proportions, there's different ways that we can write the equation of a line. And the two that we're going to focus on in this class is slope-intercept form and point-slope form. So slope-intercept form looks like this: y equals mx plus b. M is your slope, and b is the y coordinate of the y-intercept. Okay, now for point slope form, we would have this. We have y minus y1 is equal to m times x minus x1. And sometimes if you want to write it with the y isolated, you could also write it like this, where you would just add y1 to both sides. So either one is fine by me. The m, of course, is your slope. And then the x1 and the y1 is any, and I want to emphasize this, any point on the line. This equation, point slope form, has an advantage because the x1 and the y1, you can use any point from the line, whereas the slope-intercept form, you have to have a very specific point to plug into that form. You have to have specifically the y-coordinate of the y-intercept. So I find that this form, the point-slope form, is actually easier to use. However, that's up to you. You can use whichever one you want. Just make sure when you're doing your XYZ homework that if it asks you to put your answer in a specific form, that you put it in that form so that you can get credit. But when you're answering a question on the test or on a written assignment that I ask you to do, I don't particularly care which form that you write it in. Okay, so now let's go through and practice recognizing whether something is linear or not. One thing I want you to notice, when you're looking at a linear function, the degree of your x is going to be, let me write a note of this, the degree is going to be 1 or 0. If it's anything bigger than that, if it's going to be an x squared or an x cubed, then it definitely is not a linear function. So you're looking for exponents for x that's 1 or 0. Anything else is not a linear function. Okay, so looking at the first example here, it says determine whether the equation can be written as a linear function. This is definitely a linear function, and this is already actually written in mx plus b form. I know that it's linear because my highest exponent for x is 1. But also I can see that it's in mx plus b form because I can see that m is a half. That's my slope. That's the number that's in front of my x. And my b is 2. So I can identify that it's already in that form. So we would say yes, this is linear. If I look at this second example here, I notice I have an x squared and a y squared in here. As soon as I see x's and y's squared, that is no longer linear. That is something else. So we would say not linear. There isn't any way that I can rearrange this equation to put it in y equals mx plus b form. It would be impossible to try to write it in that form because we have an x squared. Okay, now moving on to describing slope of a line, and you may have seen this before, so this is probably going to be a review, but if not, it's good to go over this. There's different slopes that you can have for a line, and there's 4 particular ones. 2 are special cases. Let's go through the typical ones first. So if I have a line that as I trace it, it goes up left to right. So looking at this line, as I go left to right, I'm tracing it, it's going up. This is an increasing slope, which also means your m is going to be positive. It's going to be greater than 0. So m is positive. Okay, then we also have, let me draw this in a different color. If I draw a line and I trace it and it goes down left to right, this is a decreasing slope, which means my slope is going to be negative, less than 0. So the slope is negative. Now our 2 special cases. Okay, if I have a slope, or if I have a line that is horizontal, it has a constant slope, and it's just a flat horizontal line. This is a slope of 0. There's no tilt. And then the other special case is if you have a vertical line. This would be an undefined slope. And I'll go through and explain why that's undefined in just a second. When we go to calculate slope, we want to think of slope as the change in y over the change in x. We can write it out in words if you're not comfortable with the symbols. This triangle symbol means change. So change in y quantity over the change in x quantity. If you want to use it as a formula and you had 2 points, if I had 2 points, x1, y1, and x2, y2, and you want to use a formula, then you would just take the difference in the y's over the difference in the x's. Okay, so let's apply what we just learned. It says determine whether the function is increasing or decreasing. So we're not looking at the graph, we're looking at an equation now. So if I want to see if something's increasing or decreasing, I have to look at my slope. If my slope is positive, that means it's increasing. If my slope is negative, that means it's decreasing. So we have to identify what the slope is. The slope is the number that's in front of my x. So in this case, my slope is 5. Because 5 is positive, this would be increasing. So when I try to graph this line, it's going to go up left to right. In part B of this example, my slope is the number that's in front of my x, so that would be negative 1/3. Because my slope is negative, this would be decreasing. So that means if I go to graph that line, it's going to be going down left to right. Now, in example 2, we're going to practice finding the slope of the line given 2 points. So I'm going to call the first point x1, y1, and the second point x2, y2. And I'm going to do that for all of these. Okay, so to find the slope, we're going to take the change in y over the change in x. So I want to take my y2 minus my y1. So that's 7 minus 1 over, then my x2 minus my x1, which is 5 minus 2. So that's going to give me a 6 over 3, which is a 2. This means when I graph the line that passes through these 2 points, for every time I go over 1x, I'm going to go up 2 y values, or 2 units vertically. And this also tells me, because it's a positive 2, that it's going to be increasing left to right. So in the next example, we're going to do the same thing, y2 minus y1 over x2 minus x1. All right, so if I take my y2 minus y1, that's 7 minus 1, which is a 6 on top. And then my x2 minus x1, that's negative 3, and subtract negative 3, that gives me a 0. And when we divide by 0, that's undefined. And this ties into the fact that this is one of our special cases. This is a vertical line. If your slope is undefined, that means you're dealing with a vertical line. And let's verify that. If I were to graph the point negative 3, 1, so I come out to negative 3, come up 1, and then I graph the point negative 3, 7, so I come out to negative 3 and I go up to 7, here's 1, here's 7, and I graph that line. That's going to be a vertical line. So when you have a vertical line, you get 0 in the denominator because there's going to be no change in x. Your x's are always going to be the same value, which is why when you subtract them, you get a 0 in the denominator, which is why the slope is undefined. Let's look at part C now. We're going to take y2 minus y1 over x2 minus x1. So I have y2 minus y1, so that's 5 minus 5, which is 0 on top. And then 9 minus 4 on the bottom, the x2 minus x1, that's 9 minus 4, which is 5 on the bottom. And when I take 0 divided by a number, I can do that. That's just 0. So that's a horizontal line. That's one of our other special cases. That's when the line has no tilt at all. So we can verify that by plotting our 2 points. If I plot the point 4, 5, come out to 5, so over 4, up 5, and then over 9, 4, 5, 6, 7, 8, 9, and then up to 5 again, that gives me my horizontal line. So when you have a horizontal line, your slope is 0, there's no tilt. When you have a vertical line, your slope is undefined.